talking triangles today, and in particular area of triangles. Now if you cast your mind back into year 7, year 8, probably even primary school maths, I think, we were talking there about how to calculate the area of a triangle. And hopefully it should not be any kind of surprise to you, but when we calculate the area of a triangle, we get half of the base times the height, and that works out the area of the triangle for us. That rings bells? We're all good with that? Fantastic. And so for this kind of triangle here, we would say that's half times 14 times 5, and that equals 35. Fantastic. This type of triangle over here, it's a bit different, but we work the same thing. We've got a base, we've got a perpendicular height, and it's the same thing. Half base times the height, so it's half times 8 times 6, which is equal to 24. Fantastic, we can do that. We can even do it with triangles a little bit different like this, knowing that we still got to use a perpendicular height. This would be what our height is, that would be what our base is. And so the key idea of area of a triangle is we've got a base and we've got a perpendicular height. Perpendicular means what? Not necessarily. If the base is level, that would be straight up.
90 degrees.
90 degrees, that's right. So it's about 90 degrees, so at right angles. So perpendicular means at right angles to something else. And so the height must be at right angles to the base. Okay? Right, now, we come to a triangle that looks a little bit different. And that now becomes a little bit more problematic. Because we've been told a couple of things in this triangle. We've been told this side here, and this angle here that's in between those two. But we haven't been told the perpendicular height. How are we going to figure out what the area of this triangle is? Indeed, with that radial survey you've just been doing, how are you going to be able to work out the area of each of those triangle wedges that you just made? Because you didn't work out perpendicular heights there, did you? You were doing something else, and this is what's going to help you do it. And so, we know that the area of the triangle, let me use blue this. We know that an area of a triangle is half times the base times the height. Okay, we know that. And so I look at this triangle here and I say, okay, let's call this one the base. We've got a base. Alright, so we know that a base is equal to 10. Great, good start. Then we need to work out a height. And so what would the height look like here? It would look like this. Okay, that would be my height there. But we don't know what it is. And without knowing the base and the height, we can't work out the area. We need to work out what this height is. And so, I want to think about how using our trigonometry, how that might help us to work out what that height is. And so to help us do that, I'm going to kind of, I guess, take this part of this left-hand side of the triangle out by itself. What do I know on there?
The C angle is 70 degrees.
Okay, so that's 70 degrees there.
90 degrees.
Yep, that's 90 degrees there.
Yeah, I thought to 180, so it'll be 90 plus 70, 160, 20. 20
degrees there. Yep, we've worked that part out. There's something else we know on there from this first diagram.
9 centimetres.
9 centimetres?
Hypotenuse.
Hypotenuse, okay. Do we know this one?
No.
No.
I was going to say it's a 5. It's like half.
Well, that's assuming that that's half. But we don't know, do we? Might be, might not be. So we don't know that. Okay? Alright, let's leave that for the moment. From this over here, what do we know about this? What are we calling that? This. The height. Okay? That's the height on our big triangle that we're trying to work out the area for. Alright, so there we've got now some information on another triangle. Now this one is a right angle triangle, so our trigonometry comes into play now. Because we know our trigonometric ratios only apply to, well at the moment I should say, our trigonometric ratios do apply to right angle triangles. So, in this triangle here, let's start with our 70 degrees. I'm actually going to take this part out. Let's keep it just at 70 degrees. What side do we know? Using our trigonometry labels. What side is this one called? Hypotenuse. Okay, so using those labels. Okay? Yep. So we know a hypotenuse. What side are we looking for? And what do we call that trigonometry? Opposite. Yep. Which of our trigonometry ratios uses both those two? Side. Okay? Do you guys, I've done this with my class, I refreshed this, have you guys done it as well?
Yeah.
Yep. So remember, SOHCAHTOA, sine opposite over hypotenuse. Okay, so I know that this height, we can actually figure out this height based on sine of 70 degrees in this triangle. Okay, we can do that. And so I'll keep working on that then. So we know that sine 70 degrees equals the height over the hypotenuse, which is 9. Okay? Now if I want to work out the height, what do I need to do? How do I
divide by 9? Divide both sides by 9, so 9 comes over. So
okay.
times both.
Yeah, right, that's awesome, that's better. Okay, so times 9 times 9. Okay, what does that do? It cancels that out there, and it leaves that. So our height, and I'll write this all down, our height equals 9 times sine 70 degrees. Now I can figure that out using a calculator, but for the moment let's just leave it, okay? So that's what our height equals. Everyone okay with that? So in this triangle here, that height is the same as 9 times sine 70. Okay, so just move that bit over there, it's the same thing. So, going back up the top up here, we're working out the area of this triangle, we've got a base, we've now got something that can tell us what the height is. 9 times sine 70, again, I'm just going to leave it, I'm not going to put it in the calculator just yet. So now I've got my base, my height, I can work out my area. So the area is half times the base, which is 10, times the height, which is 9 times sine 70 degrees. Everyone with me on that? Everyone's okay with that? Right. Now I can go and put that in a calculator. If I did that, let's do it quickly. And that's 42.3 centimetres squared to 1 decimal place. Okay, if I was to work that out. 42.3 centimetres squared, 1 decimal place. Okay. But what I'm interested in is that we've just done this with numbers, but is there a way that I guess we can make a rule up based on what the process we just went through, that we could actually now create it as a formula with just letters involved, that we could then use in any type of triangle? And the answer is absolutely we can. Let's have a look at it. In this triangle here, I wrote in blue the number values, but I've also got in black just the letters. Okay, so in any general triangle, these letters can just apply. So our 10 centimetres was side A. So I'm going to take this, I'll do that actually, I'll do this. Our 10 centimetres is A, so I'm going to rub that out and put A in there. Our 9 centimetres is the same as side B. And our 70 degrees was angle C. And when I replace those numbers with, I guess, general letters to describe a side or an angle of a triangle, we end up with now this formula, which is formula for the area of any triangle. Half times A times B times sine C. What does that mean? Half times one side times another side times the sine of the angle in between. And that's the key part that you must get from the factors A, B and C. Angle C is in between sides A and B. The area of a triangle is half times one side times another side times the sine of the angle in between.